Okay, and let's look at our second problem that we're going to do factor using chunking. First thing you always want to do is look for a greatest common factor. So in this one, let's see, I don't have an x in the last term, so I can't factor out an x. 5 and 36 do not have anything in common, but they all have a y squared in them, so we're going to factor out that y squared. Pull that to the front. And when we pull that out, we're left with x to the fourth plus 5x squared minus 36. Already that's looking better to us. Now we're going to look and see, is there anything in common in these first two terms? Well, we've got an x to the fourth and an x squared. So x squared goes into both of these terms. So I'm going to substitute our chunk. Instead of an x squared over here, we're going to say let z equal x squared. So as we rewrite this, we leave the y squared out in front, and we have, instead of x to the fourth, x to the fourth is the same as x squared times x squared. So that's going to be z squared plus 5, and instead of x squared, I'm putting the z in its place, or substituting, minus 36. So now I have a quadratic expression that I've become much better at factoring. So can I factor, are there factors of negative 36 that add to give me a positive 5? So in this case there are, so we're going to rewrite this. Our factors are, we have z in both of these. So things that multiply to negative 36 but add to 5 are a positive 9 and a negative 4. Those multiply to give me the correct value and add. And at this point I'm now going to replace my z's with what we substituted or chunked out. So we still have our y squared out in front, and instead of z I replace that with x squared plus 9 and x squared minus 4. Now once we've replaced it, is there anything we can still factor? X squared plus 9, there's nothing we can factor there. X squared minus 4, sure, that's a difference of 2 squares. So we have y squared, x squared plus 9, and then we have x plus 2, x minus 2. So that would be what I would consider fully factored. Occasionally you may have, well, that's good. That's as much as we can do. We can't really factor x squared plus 9 because that's not the difference of 2 squares, it's the sum of 2 squares. So at that point we are done. Those are our factors of that nasty looking polynomial expression. Okay, a second method we can use to factor polynomials, especially of polynomials with higher order, is a method called grouping. This is very similar to what we were doing with the quadratics. But what we're going to do is group things together. So we've got 4 terms here. So we're going to just rewrite it, x third to the third plus 3x squared. And instead of the minus, I'm going to put plus a negative x minus 3. A very small distinction. But what I want to be able to do is put parentheses around the first 2 terms and around the second 2 terms. And now just looking at the first group here, is there anything I can factor out? So is there something in common in both of these? And the answer is yes. They both have an x squared. So we're going to factor out an x squared, and we're left, when we have x to the third and we factor out the x squared, we're left with x. 3x squared, we factor out an x squared, we're left with 3. So that's what this looks like. Now we have our plus here. Now in the second group here, is there anything we can factor out? The only thing they both have is a negative 1. So I'm going to factor that negative 1. And if I have a negative x and I factor out a negative 1, I'm left with a positive x. If I have a negative 3 and I factor out a negative 1, I'm left with a positive 3. So again, I took this group and I factored it. Okay, so now look at what we have. X squared times x plus 3 plus a negative 1 times x plus 3. So I'm going to look and see, is there anything I can factor out of these 2 groups? And look at that, they both have an x plus 3. So I'm going to factor an x plus 3 out of both groups that we have. Here's one group, here's the second group. So I'm pulling an x plus 3 out of my first group. So if I had x squared multiplied by x plus 3, and I divided that by x plus 3 to pull it to the front, what do I have left? And the answer is just the x squared. Now from our second term, if I factor out the x plus 3, all that's left is that negative 1. So now we have our things broken down a little bit further. We have x plus 3 times x squared minus 1. And hopefully you all recognize that x squared minus 1 is the difference of two squares. So we have to factor that a little further. And we have x plus 3, because that's fully factored. X squared minus 1 factors into x plus 1 and x minus 1. So here are your factors of that cubic that we started with. Okay, so that was done by grouping. And you can always do grouping when you have 4 terms. So let's take a look at this next one. We don't have 4 terms. But we can do the similar thing that we did with our quadratics. What do we have that multiplies to give us 45 but adds to give negative 14x squared? So our factors of 45 that add to negative 14 are negative 5 and negative 9. And what I'm going to do is break this negative 14x squared down. So I still have my x to the 4th, but that negative 14x squared we're going to break into our negative 9x squared and negative 5x squared plus 45. So again, I've broken it into those two factors that we said multiplied to give us 45, the 9 and the 5. Negative 9x squared minus 5x squared gives us a negative 14x squared. So I've just broken the 14x squared apart. And the way I knew how to break it apart were I wanted the two factors of 45. Okay, so now that we have that, I'm going to rewrite it again, and instead of this negative, I'm going to put plus, or instead of this minus sign, I'm going to put plus a negative. So it's going to be x to the 4th minus 9x squared plus a negative 5x squared plus 45. And again, it's simply so I can put parentheses and still have a sign between the two parentheses. And now I'm going to look at each group and see what can I factor out of it. In this first one, we can factor out an x squared, and we're left with x squared minus 9 inside your parentheses. And on our second one, when we're trying to figure out what to factor out, we always try and make this a positive. So let's pull out this negative here. So if I pull a negative 5 out, I'm left with x squared minus 9. And part of the way I knew to pull a negative 5 rather than just a positive 5 is that I wanted what was left in the parentheses to match this one. So this had a positive x squared, so I wanted this one to be positive x squared. Again, once we get to this stage, notice they both have an x squared minus 9, so I'm going to factor the x squared minus 9 out. So from this first term, after I factor out x squared minus 9, I'm left with x squared. And when I factor x squared minus 9 from this term, I'm left with a negative 5. Once again, I can take this x squared minus 9, recognize it's the difference of two squares, so I break it into x plus 3 times x minus 3, and I have x squared minus 5. Again, I would consider that fully factored. Occasionally you may come across people that want you to factor this further. Now, although 5 is not a perfect square, we're going to use the same rationale of how to factor it. So let's put our x plus 3, x minus 3. And the way we got these values, remember, the positive 3 and negative 3 are the square roots of 9. So if I wanted to do the same thing here, I can break this into x plus and x minus, and you can only do this if it's a difference. And what we'll go here is the square root of 5 and the square root of 5. So fully factored, as far as you can possibly make this go, would be x plus 3, x minus 3, x plus the square root of 5, and x minus the square root of 5. And that would be considered fully factored. Now let's do a couple more, just because I think there weren't enough examples here. So if you just turn over your paper, we'll do a couple more for practice. Okay, so let's say we have x cubed plus 5x squared minus 4x minus 20. And we want to factor this by using grouping. So again, if you have 4 terms, you definitely would prefer grouping. So we rewrite this because I need to have, what I need to do is put parentheses around the first 2 and the second 2. So I'm going to have x cubed plus 5x squared plus a negative 4x minus 20. Put those parentheses around. And now looking at our first group, what can I factor out? In this case, it looks like an x squared. What's left is x plus 5 plus, and again, we want what's left to match this one. So I want to pull out the negative 4 from both terms. So negative 4, I'm left with x plus 5. Okay, so in this first group and in this second group, they both have an x plus 5 as a factor. So I'm going to factor out the x plus 5. And again, you need to keep that in parentheses. And what was left from the first term when we factor out x plus 5 is just an x squared. And what's left from the second term when we factor out x plus 5 is just the negative 4. And of course you recognize we're not done factoring yet. So we're going to take that x squared minus 4 and break it down further. So we have x plus 5 times x minus 2 times x plus 2. There you go. Those are our 3 factors of the polynomial that we started with. Okay, let's do one more example here, and then we'll be done. And you can start on the homework. Okay, so let's have 2x cubed minus x squared plus 50x plus 25. So again, since we have 4 terms, we're going to go ahead and put parentheses in. Notice I already have this addition sign. So I'm just going to go ahead and put those parentheses around. And now looking for what's in common in the first term. So they both have an x squared. So we're going to factor that out. And we have 2x minus 1 left. In our second group, it looks like they both have a 25. So we're going to factor out a 25. Let's see what we get here. So we get 2x plus 1. Doesn't quite work, does it? What did I do wrong on this guy? Oh, excuse me. This should have been a negative 50x when we started. So negative 50x there gives us a negative 2x plus 1. But notice these are not the same sign here. So what would I have to factor out of this to make it look like this? So keep in mind, we want negative 2x plus 1 to become positive 2x minus 1. To do that, I'm going to have to factor out a negative 1. So if we pull out a negative 1, we're going to have x squared times 2x minus 1. I'm pulling out a negative 1, so I have plus 25 times negative 1 times 2x minus 1. So now we've got the correct signs. So we have the same values here. And let's just rewrite it, because 25 times negative 1 is simply a negative 25. So x squared times 2x minus 1 minus 25 times 2x minus 1. And again, we notice we've got the same term, which was our goal. So we're going to factor out 2x minus 1, and we're left with x squared from the first term and a negative 25. Again, Got the difference of 2 squares, so we take it one step further and break that down into the two factors x plus 5 and x minus 5. And there you go. There are the 3 linear factors of the cubic that we started with. And again, change it on your paper so you know that that was a negative 50x. Okay, good luck on the homework. I will be around if you have questions.